Hello again, gang. Mr. Cruze here, working through the geometry review for the Chapter 10 Part 1 test. In this video, we're going to continue onward. So, 14 and 15, I scrolled down a little too far. I want you to find the measures of the numbered angles in the following regular polygons. Okay, regular, of course, meaning all sides congruent and all angles congruent. Okay, so that'll be very important. If they're not regular, it's a little more difficult to figure out the area of them. In some cases, often impossible without a lot of given information. Okay. Anyway, finding the measure of the number of angles is very important for finding the area, and we'll see why in a little bit. Anyway, angle 1. What I notice is there are basically 5 of those angle 1s. These are all angle 1, right? And they're all congruent. So anyway, you take 360 divided by, really, it's the number of sides. Okay, 360 divided by 5 is 72 degrees. Okay, but anyway, so that's the measure of angle 1, 72 degrees. Angle 2, you will recall, is part of our little triangle that we always make when we're finding the area. It's half of that entire 72 degree angle. So measure of angle 2 is 36 degrees. It's half of 72. This entire angle is 72, and the apothem here bisects that angle. All right. And the measure of angle 3 is, of course, complementary. Remember, complementary means adds to 90 with angle 2. So you take 90 minus 36, and you get 54 degrees. Pretty simple there. Okay. Same thing over here. The only trick is how many sides do we have? So let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a decagon. So to get angle 1, which is kind of hidden in there, I take 360 divided by 10. Which of course gives you 36 degrees. So that's the measure of angle 1. Again, angle 2, the apothem splits the 36 degree angle in half, so that'll be 18 degrees. And I know angle 3 is over here this time, but remember angle 2 is just the same right there and there. So again, it's complementary, so you take 90 minus 18, which means the measure of angle 3 is 72 degrees. Interesting. There's some sort of correlation there. Okay, this is a pentagon, this is a decagon. Pretty simple. All right, and these begin the tricky ones. Let's find the area of these regular polygons. You'll notice sometimes they'll give you pictures, sometimes they won't. Okay, but really we know that we don't need the whole picture. We really just need this triangle right here. So I'm going to redraw it just so it's bigger so we can use it. Your triangle, of course, doesn't have to be perfect, right? Anyway, the 16 is technically down here, right? But we want half of it, which remember, the apothem not only is an angle bisector, it's also a perpendicular bisector as well, right? So this is 8 centimeters. It's half of the 16. And you'll remember the area formula is 1/2 the apothem times perimeter. Well, this is the apothem. We need to figure that out. Perimeter is easy to get. If all these sides are 16, and there are 6 sides, that means the perimeter is 6 times 16, which is 96 centimeters, okay? So let's find the apothem. Well, to do that, we need to figure out this angle at the top. So I take 360 divided by twice the number of sides. Since there are 6 sides, I'm going to take 360 divided by 12, and I get 30. So those of you at home might recognize this as a 30, 60, 90, but I'm going to use trig to find A. So 8 is the opposite, A is the adjacent. So I'm going to use tangent of 30 equals 8 over A. Pull the old switcheroo, 8 over tan of 30. And you take a quick second and you plug it in your calculator and you get 13.8564. Remember, I told you 4 decimal places in the middle of the problem, okay? Anyway, you've got your perimeter, you've got your apothem, so you're ready to rock and roll. 1/2 the apothem times the perimeter. And then you just plug that in your calculator and round to the nearest tenth at the end. And you should get this. And if you do, you win 665.1. Don't forget your units. Square centimeters. Alright. A little bit of work, yes, but worth it in the end. Okay. Here's a triangle we're going to be looking at in this one. This one's a square, by the way. You may notice the whole shape is a square. We didn't work a whole lot with squares, but that's okay. They behave the same way, right? So let's see. We have our triangle. Doesn't really matter which way it's facing, by the way. 26 is what's known as the radius, and that's the trickiest one. When they give you the radius, you have to find not only the apothem, but you also have to find half of the side length, right? So, it's your choice what you want to do first. We have to do 360 divided by twice the number of sides. So in this case, there are 4 sides. So 360 divided by 8 is 45. Ooh. There, we can kind of use a little bit of a shortcut here. Since this is a 45, 45, 90, I know that A and B are congruent. So really, I only have to find one, and boom, I've got the other. So let's just find A. A is the adjacent. 26 is the hypotenuse, so that'll be cosine of 45 equals A over 26. That means A equals 26 times the cosine of 45, and you should get 18.3848. Okay? By the way, that means B equals the same thing. Now the big question is, how do I turn B into a perimeter? How do I get all the way around it if B is only half of a side? First thing you always want to do, you take B times 2 times the number of sides. That'll give you your perimeter. Okay? So anyway, we're going to take 18.3848 times 2 and then times 4. And my perimeter in this case equals 147.0784. Perimeter, apothem, you're ready to go. Area equals 1/2 the perimeter times the apothem. So let's see what that multiplies to. Times 18.3848. If you're wondering what I'm doing, I am plugging in my calculator as we're working. It comes out to be 0.003484, so you try to round to the nearest tenth, and there's really not much there to round for, so there it is, 1352 square centimeters. Alright, octagon with apothem 15 feet. Okay, apothem's nice. That's part of our area formula, right? Area equals 1/2 the apothem times the perimeter. Well, if the apothem is 15, how can I use that to get the side length? Well, we need to start with the angle again. You'll notice every time we're doing this, 360 divided by twice the number of sides. So what is 360 divided by? Well, it's an octagon. That means 8 sides, right? So 360 divided by 16 gives you an angle of 22.5 degrees, right? B is the opposite. 15 is the adjacent, so we're going to use tangent of 22.5, and that equals B over 15. So multiply both sides by 15, and I got B to be 6.2132. Again, just like before, double this and then multiply by the number of sides, which is 8. So I'm going to take 6.2132 times 2 times 8. So my perimeter is 99.4112. And then you just plug it in your formula. 1/2 the apothem, which was 15, times the perimeter, 99.4112. Multiply it out on your calculator. Let's see, 15 times 0.5 times 99.4112. I get an area of 745.6 square feet. Okay. Apothem, not so bad, right? Radius was the tricky one. And, of course, we're with another radius. Alright. So, radius in your little triangle goes where? Well, it goes in the hypotenuse. This will be the radius, 21.4 meters. Okay. So we need to find the apothem and the side length. Again, these are the trickiest ones. Okay. When they give you the radius, you have to find the apothem and the side length. Alright. Anyway, let's figure out the angle. It's 360 divided by twice the number of sides. Deca means 10 sides. Not the same as the deca we have here at school. Okay, so 360 divided by 20 is 18 degrees. So B is opposite, A is adjacent, 21.4 is your hypotenuse. We can't use the same trick we used in the square, where A and B were actually congruent. That doesn't work here. So we're going to have to find them separately. Let's find A first. Well, A is the adjacent, and we know the hypotenuse, so that'll be cosine of 18 equals A over 21.4. So I'm going to take 21.4 times the cosine of 18, that'll equal A, which gives me 21.4 cosine of 18 I get 20.3526. There's my apothem. That'll be useful later. Let's find b now. Well, b is the opposite, and we have the hypotenuse, so that'll be sine. You'll notice if they give you the radius, you're going to use sine and cosine. If they give you either the apothem or a side length, you're going to be using tangent. So that'll be an interesting observation. We'll see what you guys do with it tomorrow. Anyway, 21.4 times the sine of 18 is going to equal b. Let's see, 21.4 sine of 18 gives me 6.6129. Oop, that 29 will round up to 30. Anyway, double the b. Remember, multiply by 2 because it's half of a side. And then you're multiplying by the number of sides, which was 10. So my perimeter is 132.26. And boom, you've got enough to do the area of the regular decagon with radius 21.4. What you thought was an insurmountable challenge is actually now rather mundane. So 0.5 times 20.3526 times 132.26. I get an area of 1345.9 square meters. Okay, and we win.